Okay, imagine this. It's 1908. In the remote, sprawling forests of Siberia, something with unimaginable power detonates in the sky. It leaves behind total devastation, but no obvious culprit. For more than a century, this event was one of history's greatest unsolved cases. So today, we're going to dive into this cosmic crime scene and see how science, step by step, finally cracked it.
Just to give you a sense of the scale here, we are talking about an explosion with the energy of 15 megatons. That is 1,000 times more powerful than the bomb that fell on Hiroshima. It's on par with some of the biggest hydrogen bombs ever built. This was, and still is, the most powerful impact event in all of recorded history.
So an explosion with that much energy, you would expect to find a massive hole in the ground, right? A giant crater. But that is the central mystery of Tunguska. Investigators get there and they find a flattened forest, but no crater. None. This one single paradox baffled scientists and, it fueled all kinds of wild speculation for decades.
To solve this, we have to start right where it all happened, the crime scene. So let's wind the clock back to that morning and take a look at the physical evidence that was left behind by this completely bizarre and craterless catastrophe.
The very first clue is just the sheer scope of the damage. We're talking about a shockwave that leveled 2,150 square kilometers of forest. That's an area larger than all of Greater London, bigger than New York City's 5 boroughs put together. But it was the pattern of all that destruction that turned out to be the most revealing clue of.
Within that massive zone, something like 80 million trees were just snapped like matchsticks, and they were all pointing away from a central point, like spokes on a wheel. But here's the really weird part. Right at the very epicenter, the trees were stripped of all their branches, but they were left standing straight up, like a forest of creepy telephone poles. This strange pattern was a huge piece of evidence, and it pointed away from a ground impact.
And this brings us to our prime suspect, an airburst. So instead of slamming into the ground, the object, we think a stony asteroid about 50 to 80 meters wide, disintegrated high up in the atmosphere, somewhere between 6 and 10 kilometers up. The unbelievable pressure of entering the atmosphere caused it to just explode, turning all of its forward speed into this catastrophic downward blast of heat and pressure.
Okay, so we have a theory, but how did we even get there? Well, the investigation didn't start for a long time. Let's take a look at how the first detectives on the scene began to piece this puzzle together, even though they had a nearly 20-year delay.
You have to remember, this happened in one of the most remote places on Earth. And before anyone could even think about mounting a serious expedition, Russia was thrown into World War I, then the Revolution, then a civil war. It wasn't until 1927 that a mineralogist named Leonid Kulik finally made it to the site, guided mostly by stories from the locals. It was Kulik who first documented that telegraph pole forest and the completely baffling lack of a crater.
Kulik's most valuable clues didn't come from rocks. They came from people, the indigenous Evenki people. Their oral histories were incredibly precise. This account from a man named Semenov, who was over 60 kilometers away, perfectly describes the sequence. First, a blinding flash of light, then this intense wave of heat, and only after that did the devastating shockwave arrive. These human stories were really the first true data points in the whole investigation.
So for decades, the airburst theory was the best fit. But direct proof? It just wasn't there. The case basically went cold. And then, over a century later, a forensic breakthrough, using technology the first investigators couldn't even dream of, finally found the smoking gun that had been hiding in plain sight the whole time. While Kulik was trekking through the swamps looking for big meteorite chunks, the real evidence was microscopic. In 2025, scientists went back, they dug into the soil, specifically looking for a layer of Earth from 1908. And what they found in that dirt, it fundamentally changed everything we thought we knew about the event.
And here it is. This is basically the forensic report. What they found were these microscopic grains of quartz with fracture patterns that can only be formed under immense, instantaneous pressure, the kind you only get from a high-velocity impact. They also found these tiny little spheres of melted quartz and other minerals. The critical point is that making these things required conditions way more extreme than any forest fire could ever produce.
Just look at this number. 1,710 degrees Celsius. That's the temperature you need to literally melt quartz sand into glass. A raging forest fire, it might peak around 800, maybe 1,000 degrees. This discovery was the definitive proof. It meant that while the main asteroid exploded in the air, a shower of superheated, high-velocity fragments did actually reach the ground, creating these little localized zones of extreme heat and pressure. The craterless event, it wasn't really craterless at all. It just left thousands of microscopic impact sites. Case closed.
Now, trying to understand the physics of an event like this was really hard, until 2013, when history sort of repeated itself. But this time, the whole world was watching on dashcams. The Chelyabinsk meteor event over Russia became our modern-day Rosetta Stone, helping us finally decode what happened at Tunguska.
First, let's just compare the raw power. Chelyabinsk released about 500 kilotons of energy. It shattered windows all across a major city. But Tunguska, as you can see, was up to 30 times more powerful. So why was one a major incident and the other a continental-scale catastrophe?
The answer is altitude. It's all about altitude. As this table shows, the Chelyabinsk object blew up way up high, around 30 kilometers. Most of its energy just dissipated harmlessly in the upper atmosphere. But the Tunguska object was much bigger. It penetrated way deeper into the atmosphere, and it exploded at just 6 to 10 kilometers up. At that low altitude, the full force of the shock wave and the thermal pulse slammed into the ground, causing total devastation.
So we've identified the weapon and the method, but what about the motive? Was Tunguska just some random freak accident? Well, newer research suggests it wasn't random at all. It was actually part of a predictable, recurring pattern, a kind of conspiracy of physics.
This brings us to a really fascinating theory called coherent catastrophism. The basic idea is that our solar system isn't just an empty shooting gallery. It's filled with these dense streams of debris left over from ancient comets. And the Tunguska object? It's now believed to have come from one of these streams, called the Taurid resonant swarm. What that means is our planet's risk of getting hit isn't constant. It actually spikes whenever we pass through these cosmic minefields.
And this is exactly why solving a 100-year-old cold case matters so much today. Scientists can now predict when Earth is going to pass through the densest parts of the Taurid swarm again. As you can see on this timeline, we've got key risk windows coming up in 2032 and 2036. And that 2036 window, it involves the very same branch of debris that produced the Tunguska impactor.
So it's pretty incredible when you think about it. The long, slow investigation of a mysterious explosion in the Siberian wilderness has led us directly to the forefront of modern science, planetary defense. The ghost of Tunguska is now shaping global policy and our mission to protect Earth from future impacts. All right, let's officially close the case file. The culprit? A stony asteroid from the Taurid swarm. The method? A devastatingly low-altitude airburst. The proof? All that microscopic evidence of fragment impacts. This explains the whole scene. No single giant crater, but widespread devastation. And the motive? Not malice, just predictable physics, as our planet takes its regular trip through a dangerous neighborhood. Ultimately, Tunguska was a dress rehearsal. It was a warning shot. It showed us what even a relatively small asteroid can do if it happens to explode over land. The difference today is that the next one might not detonate over an empty forest. So the 1908 event wasn't just a mystery to be solved, it was a clear warning. And the real question for us now is, are we ready for the encore?